Okay guys, here we go. I'm going to continue my little series on the hormones that affect metabolism. So today what I'm going to do is I'm going to talk to you about the thyroid gland and thyroid hormone. Again, the master gland, the pituitary gland, controls the release of other hormones from other glands. In this case, the pituitary gland releases the hormone thyroid stimulating hormone, or TSH. And that will stimulate the thyroid gland to begin the production of active thyroid hormone. And the thyroid gland, located at the base in your neck, looks kind of like a little butterfly. And the function of thyroid hormone, couple. Number one, it controls your basal metabolic rate, meaning how many calories you burn at rest. I'll show you a little bit about that. Number two is it increases protein synthesis in literally every cell. So because building protein, building stuff requires ATP, right? This is how it works in controlling your basal metabolic rate. So if you have too low a thyroid, you're not going to be building proteins. You'll be breaking down proteins, but you won't be putting them back together. So that means that you won't need as much ATP. The result is that anything you eat is not going to be used to make ATP inside your cells. Instead, it's going to be converted in the liver to fat. That's why people with low thyroid tend to gain weight. The other thing it does is it stimulates cell division. And then a couple of other things. In the fetus, it increases the development. Oh, you know how to spell it. Of the nervous system. So if a fetus is developing and they lack thyroid hormone, they develop a condition called cretinism. They tend to be very short of stature, right? They're small. They have a small cranium, and they are usually profoundly retarded. And then in adults, severe hypothyroidism in adults can lead to a condition called myxedema. And I may or may not get to cover that. But anyways, so let's talk about this. First of all, I hate to do this to you, but we got to go back to the cell. So if you look, and this is, any cell. You got a little capillary, and then you have the cell membrane. All right, who cares what cell it is? Got the cell, got the capillary. And embedded in those cells are these little protein ion leak channels. And then, of course, we have our buddy, our pal, the sodium-potassium pump. And again, sodium highly concentrated in the blood, potassium highly concentrated in the cell. And sodium will leak in, potassium will leak out. And what the pump does is it takes 3 sodiums, a bunch of sodiums leaked in, but the pump takes 3 of them that leaked in and will pump them back into the blood, and we'll take the 2 potassiums that leaked out, potassium leaking out, and it will pump 2 potassiums back into the cell. And because you're going against a concentration gradient, that cell has to use ATP. Now, One of the things that thyroid hormone does is it will make cell membranes more leaky to sodium and potassium. So in order to maintain the concentration of sodium, right, 135 to 145 milliequivalents per liter, and to maintain the concentration of potassium in the cell, or we can't measure that, so the 3.5 to 5.5 milliequivalents per liter in the blood, right, the sodium-potassium pump has to work harder, and that requires ATP. So the more ATP you use, the more energy you're going to have to break down inside your cells, glucose or fat, to make that ATP, to make that pump work, so you keep the concentration of sodium and potassium in the blood at homeostatic levels. So in the case where you have too much thyroid hormone and sodium starts leaking in more and potassium starts leaking out more, then the sodium-potassium pump has to work harder. Therefore, you're not going to have food that you ate and broken down get stored in fat. You're going to need that to break that down inside glycolysis and Krebs cycle to make that ATP, to make that sodium-potassium pump work. So in hyperthyroidism, you are going to have weight loss, right? That's a sign. The other thing, remember that when you break off that third phosphate on ATP, you produce heat. So these people will have an intolerance to the heat, right? They're always hot. Again, everyone's entitled to their own opinion. You know, some people are hotter than others, but I digress. Now, it also increases protein synthesis, right? So increase connective tissue, right? So you got this protein in the back of your eye, and it will cause that protein to thicken and will cause your eyes to bug out. So those are some basic signs and symptoms of hyperthyroidism. But let's get back now to the thyroid hormone as a whole. So again, remember, the hypothalamus and the pituitary gland are intimately linked. And if there is a drop in basal metabolic rate, for whatever reason, right, or an extended period of a person being exposed to cold, right, so their body temperature begins to drop, the pituitary gland is going to release the hormone, thyroid stimulating hormone. And it affects the thyroid gland. It affects other tissues, but primarily the thyroid gland. And any cell that has TSH receptors is going to be affected by thyroid stimulating hormones. So you got your thyroid gland cell. Right? And you're not going to believe this, but embedded in the thyroid gland cell is a receptor called TSH receptor. Now, one of the things that's an absolute requirement for you to build active thyroid hormone is iodine. And you get iodine from iodized salt. And the only cell of the body that uses iodine is the thyroid gland to make active thyroid hormone. Now, what happens is this, and again, I'm going to try and simplify this. Drop in basal metabolic rate, TSH is released from the anterior pituitary. It's going to bind to TSH receptors on the thyroid gland cell. Yeah. And it is then going to stimulate iodine pumps in the cell membrane of the thyroid gland. And what that pump will do is it will take the iodine from the blood and pump it into the cell. Thyroid stimulating hormone also stimulates the production of enzymes that will begin the protein portion of the thyroid hormone, but I'll skip that. So in the thyroid gland cell, you will begin to manufacture T4. T4 is thyroxine. And the reason it's called T4 is it has 4 iodine atoms connected to that protein structure. Thyroxine is biologically active in terms of being a thyroid hormone. But this is what's going on. Once this is produced in the thyroid gland, T4 then exits the thyroid gland cell through the process of exocytosis, gets dumped into the blood, and then it circulates to the liver. So you got T4 in the blood. Yeah. Then you go to the liver. And in the liver, there are enzymes, right? T4 gets taken up by the liver cell, and T4 gets converted to T3. T3 is called triiodothyronine. I'm assuming that you like T3 better than the name triiodothyronine. And T3 gets dumped into the blood. T3 is the most powerful form of the thyroid hormones. T4 is the most numerous, but T3 is the most biologically active. And again, what are its functions? Its functions are to increase your basal metabolic rate. And one of the ways it does that is by making cells more leaky to sodium and potassium, and therefore making the sodium-potassium pump have to work harder. So anytime you use ATP and you break off that third phosphate, you are going to produce heat. So again, it is the heat, the increase in protein synthesis, right? Because that's one of its functions, and because you're not storing any excess calories as fat because you're burning them, breaking them down inside the cells of your body to keep that sodium-potassium pump running. A sign of hypothyroidism is weight loss. The other thing is T3 increases cells, it increases cells' sensitivity to the catecholamines. Oh, nice. That's a fancy way of saying catecholamines are epinephrine, epi, and norepi, right? So if you have increased amounts of T3 circulating, it is going to amplify the effects of epi and norepi, right? So what does epinephrine, when is epinephrine released? When you're scared. So what's going to happen to a person who is hyperthyroid? You got a lot of T3 floating around. It's going to make all your cells more sensitive to epi and norepi. So in the heart, it's going to increase their heart rate and increase the force of contraction of their heart. And that's going to increase their blood pressure. So people who are hyperthyroid are referred to as being hyperdynamic with respect to the cardiovascular system. Their heart rate's high, their blood pressure's high. Also, because epinephrine increases, right, increases metabolism within cells, that's going to aid in that weight loss and that production of heat. The other thing is that high levels of thyroid hormone are going to activate the central nervous system. So it is going to be more active. Yeah. So the nervous system is going to be stimulated. So these people will, if it's high enough, they will get agitated, right? They will have zero or little patience with people, right? They will develop insomnia, right? So with the high levels of thyroid hormone circulating, you can't turn off your central nervous system. If you can't turn it off, you can't sleep. And in some cases of really high levels of thyroid hormone, you can affect the heart where you go into a lethal arrhythmia called ventricular tachycardia or ventricular fibrillation. And some people will actually die from that. So those are really the effects of high levels of circulating thyroid hormone. Just a couple of other things too. Remember that one of the effects of thyroid hormone is to increase cell division. So if you remember, the skin cells divide rapidly. So if you increase the rate of cell division, right, and that's what thyroid hormone does, skin divides pretty fast, but it divides at a rate that allows, as that skin is moving up from the basal layer of the epidermis to the surface, it gets keratinized. But in this case, because it divides so fast, they tend to get like this scaly, like red, rough skin. And because hair is keratinized skin cells, the cells divide so rapidly that you will start to lose hair. And it will become, your hair can actually become thin. So that's another sign that your thyroid level is elevated. So if you look at the signs of hypothyroidism, right, low levels of thyroid, right, hypothyroidism, well, it's pretty much the opposite of hyper. I mean, go figure. Let's go back. In hypothyroidism, the cells of the body become less leaky to sodium and potassium. That means that the sodium-potassium pump, which is ATP dependent, doesn't have to work as much. So if the sodium-potassium pump doesn't have to work as much to make ATP, any calories that you take in, or, you know, not every calorie, but if you took in the same amount of calories and then you developed hypothyroidism, those excess calories aren't being used to make ATP to make that sodium-potassium pump run. So the result is going to be increased body weight, right? They will gain weight. There will be decreased protein synthesis, so they will get muscle wasting. And because the skin cells don't divide very well, they will start getting what's referred to as pretibial edema, and the skin will start kind of looking nasty and rough. And that's because the skin cells are dividing so slowly, right? And the skin kind of gets kind of callousy. The other thing, right, in hypothyroidism is because thyroid hormone increases the effect of the catecholamines, epinephrine and norepinephrine. So if you're hypothyroid, you will have decreased sensitivity of epi and norepi. Right? So what is that going to do? That's going to decrease your heart rate, decrease your force of contraction of your heart, and decrease your systolic blood pressure. So they can be hypotensive. They can actually get postural hypotension, so you stand up and you start getting dizzy and lightheaded. And they will have decreased central nervous system stimulation. So in severe cases, it can lead to depression. These people are tired all the time. They're sleeping all the time. And in really severe cases, you will start getting what's called mucopolysaccharides and some protein. So this kind of slimy, sugary mucus begins to build up in the skin. So they get this slimy protein mix building up in the dermal layer of the skin. So they will get puffy. There we go. Here. Myxedema. So, and this puffiness is all over the place, and they'll even develop ascites, and a lot of that has to do with shifts in fluid due to you're not making albumin, right? So if you're not making the protein albumin, it's going to cause water shifts, fluid shifts. So they'll get this condition called myxedema. So the severest form of hypothyroidism is a condition called myxedema, and I just showed you a picture of that. The other thing is that their GI activity is going to slow down, so they develop constipation. So how do you check for, or how do you screen for hypothyroidism? Well, first of all, you look at the patient, right? And the screening blood test is the thyroid stimulating hormone. Now again, thyroid stimulating hormone stimulates the thyroid gland to release thyroid hormone. So here's your thyroid gland cell, here's your little TSH receptor, here's TSH. If and when TSH binds to that receptor and causes the release of T4, production of T4, and release from the thyroid gland cell into the blood, and then it goes to the liver and is converted to T3, then that's going to feed back on the pituitary gland and shut off the release of TSH. So in hyperthyroidism, low thyroid, their TSH will be elevated. In hypothyroidism, hypothyroidism, their TSH will be elevated. In I wish I could spell, hyperthyroidism, right? The thyroid gland is pumping out T4, it's going to get converted to T3 in your liver. And that elevated T4 and T3 is going to feed back on the pituitary gland and say, don't release any more thyroid stimulating hormone for hyperthyroidism, right? So hyperthyroidism, too much thyroid, that's going to feed back on the pituitary and stop the release of TSH. In hypothyroidism, watch, hypo, that you're not releasing enough thyroid hormone T4, you're not making enough T3. So there's nothing to feed back on the pituitary gland to tell them, hey, don't release any more TSH. So in hypothyroidism, your TSH is going to be elevated, and in hyperthyroidism, your TSH is going to be low. Now, remember that T4 goes to the liver and is converted to T3, right? So remember, when an organ fails, all the functions of that organ fail. So one of the things that can happen in people who have liver failure is they can develop symptoms of hypothyroidism because you can't convert the T4 to T3. So the other symptom that you would see in people with either hyper or hypo, mostly hypo, is the body does stuff that makes sense. The only cell of the body that uses iodine is the thyroid gland. So if you have low iodine, what will happen is you will start, those thyroid gland will start to get bigger, there, a little hypertrophy, and you get a goiter. That's a good word, goiter. So during a physical exam, doctors will examine your neck and look at the size of your thyroid hormone. So in addition to blood tests, they'll do the physical exam to see if you have hypertrophied thyroid hormone. So I hope that helped a little bit, and I'll post this soon.